Varying degree of shuffling using random module Python. I am using two architecture programs with visual programming plugins, Grasshopper for Rhino and Dynamo for Revit, for those that know, are interested. Grasshopper contains a function called jitter. This will shuffle a list, however it has an input from 0.0 to 1.0 which controls the degree of shuffling. 0.0 results in no shuffling, 1.0 produces a complete shuffle. The second of the programs, Dynamo, does not contain this functionality. It contains a shuffle module, which contains a seed value, however it is a complete random shuffle. Ultimately the goal is to produce a series of solid and glazed panels, but to produce a slight random effect, but avoiding large clumping of solid and glazed elements, hence I want a light shuffle. I have written a code which will calculate the number of glazed, true, and solid, false values required and then evenly distribute true and false values based on the number of items and percent specified. I have checked out the random module reference, however I am not familiar with the various distributions as described. Could someone help out or point me in the right direction if an existing function would achieve this? I have cheated slightly by adding true-false alternately to make up the correct number of items within the list. List 3 is the final list. List 2 contains the repeated module of true-falses. Many thanks.
The other algorithms you're referring to are probably using the Fishy-Yates shuffle under their hood. This O(n) shuffle starts with the first element of an array and swaps it with a random higher element, then swaps the second element with a random higher element, and so on. Naturally, stopping this shuffle before you reach the last element at some fraction, 0, 1, would give a partially randomized array, like you want. Unfortunately, the effect of the foregoing is that all their randomness builds up on one side of the array. Therefore, make a list of array indices, shuffle these completely, and then use the indices as an input to the Fishy-Yates algorithm to partially sort the original array.
There's no clear definition of what degree of shuffling, D, means, so you'll need to choose one. One option would be, the fraction of items remaining unshuffled is 1D. You could implement that as, produce a list of indices. Remove 1D, *n of them. Shuffle the rest. Reinsert the ones removed. Use these to look up values from the original data.
Here is an approach based on this paper which proves a result about the mixing time needed to scramble a list by using swaps of adjacent items. A test, each line showing the result of jitter with various percents being applied to the same list. Typical output. I'm not sure how principled the above is, but it seems like a reasonable place to start.
I believe I found a more versatile, robust, and a consistent way to implement this adjustable shuffling technique.
If you wanted to boil it down, but you can still like and subscribe it.